A football stadium has 9 gates, 4 on the north side, 5 on the south side. How many ways can you enter and leave the stadium if you must enter through a south side and exit through the same gate? Oh, this is going to be a fun day if this is what it's doing. All right, so we have 2 blanks. We have an enter blank and an exit blank. How many options do we have for the enter blank? Needs to go through a south side. 5. And then must exit through the same gate. 1. So it's 5. Now here it says, in how many ways can you enter through a north gate and then leave through any other gate? So north gates there are 4. How many gates in total? There are 9, correct? And I need to leave through a different gate. So how many are going to be here for the leaving gate? 8. 32. Then here it says, how many different arrangements can be made using all the letters in the word mammal? So I'm going to immediately start stacking. If the vowels must be together. So I'm going to go like this and go 3 factorial, 2 factorial in brackets if I don't do the fraction button. Now the vowels must be together. There are 6 letters. 1, 2, 3, 4, 5, 6. Hook the vowels together. That's a lie. Hook the vowels together. Ignore that. There are 2, then 1, then 4, 3, 2, 1. Am I done? What do I have to do? Times it by 5, because there's 5 places where those vowels can move. They would still be together and you get different words. So technically, if you want to write in short form, it'd be 5 factorial times 2 over 3 factorial times 2. The 2's could cancel. So it should be 120 divided by 6. What did you get? Now here it says the m's cannot be together. How do we do cannot be together? We do total no restrictions minus the m's together, and you get the m's not together, right? So total ways you could do mammal is 6 factorial over 3 factorial, 2 factorial, the word mammal. And then we're going to subtract off all the ways the m's can be together in mammal. 1, 2, 3, 4, 5, 6. Now I can hook 3 letters together. 3, 2, 1, 3, 2, 1 times 4. And what do we get? What do you get for an answer?
A little different than how we were interpreting the question.
What?
Would the m's still be together if, say, 2 of them were together and 1 of them was disconnected?
Oh, they're not going to do 77 cases.
Yeah,
it's just
right.
m's together.
Okay, that's why at least for me, I think a bunch of other people did this, is we did the 4 cases where they're all separated and then calculated that.
Stop overachieving, okay? It's just m's together. Yeah.
I did not overachieve and I got 40.
Thank you. Yeah, when they say m's together, they should say all m's together, but they'll say m's together. I get what you're saying. I see what you're doing here. And this is why in lies the issue of when they do diploma-style questions, they do field testing of the questions first. And what will happen to actually get a test question kicked out, or we have to redo the question before it can make it to a diploma, is the top-ended kid gets it wrong more than the bottom-ended kid. It'll get tossed, because what it means is it's worded in such a way that you guys can overachieve and underachieve, essentially, due to your overachieving. It's really kind of a bummer. So what they always look for is that the top end, the middle, and then the bottom get it right in increasing order. So this would have to be a higher end, the middle would have a little bit less correct, and then the bottom end would have less correct, because essentially it might be just guessing at this point. So they'll always slot that field test to who has the higher marks to middle to bottom, and then all the multiple choice need to fall in that order. And if they don't, there could be something like this that you're misinterpreting that someone else isn't. And then they have to change the word or do something or figure out why it might be the case that you guys are flip-flopping. And then they look at the answer that you are picking and figure out what you're doing. Okay, 5 people, Anna, Bob, Cleo, Dinah, and Eric, or we could call her Dina, I don't know, I put her on there, are seated in a row. In how many ways can they be seated if Anna and Cleo must sit together? So 1, 2, 3, 4, 5. Sit Anna and Cleo together. It doesn't say what order, so it can go 2, 1, 3, 2, 1, times 4. And we get 2 times 4 factorial, which is 40. 8. Anna and Cleo must sit together, and so must Dina and Eric. 1, 2, 3, 4, 5. So we make Anna and Cleo sit together. We make Dina and Eric sit together. So we have 2, 1, 2, 1, 1. That just orders them in where they're sitting, correct? Making them sit together. But then what do I still have to do? Rearrange all those spots that those sections could move. So how many sections do I actually have? I have 3. So what I can do is now follow behind with the 3 sections and order them. 3, 2, 1. Because there are 6 ways that you can order those 3 pieces, right? If I just gave you 3 blanks and told you to order the 3 blanks, you could have 3 for the first one, 2 for the second one, and then you'd have to put whoever's left at the end. So in this case, you actually have to order the blanks, and then you have to order the spaces. So it's going to be 24. And then Anna and Cleo must not sit together. So 5 factorials, total, no restrictions, minus Anna and Cleo sitting together, which we already know is 48. And what do we get for an answer?
72.
Voila. Because you haven't actually ordered them sitting here. So if I have Anna and Cleo and Dina and Eric, and then I don't remember who the other person was, I can now do this and keep them here. Then I can move these 2. Then I can move these 2, and I'm still going to get a new seating plan with those 2 together. So like I have 2 people together, so I just go 2, 1. Then I have 2, 1, and then I have 1. All I've done so far is just rearrange 2 can sit together. Now I actually have to order where they're sitting. Because now I have, say, Dina and Eric here, and Anna and Cleo here, and then the B person, I don't remember their name. Then I can go like this. I can move this person here, totally different arrangement. This group of people here, this group of here, I can swap them, totally different arrangement. So there's 6 ways I can swap the groups after I've just ordered the people. So I have to order the 2, 1, 2, 1 because Anna and Eric, Dina and Eric, Anna and Cleo can swap spots. So I only ordered that at first. All I did was order those guys, moving their spots. So Anna and Cleo, Cleo and Anna, Dina and Eric, Eric and Dina. All I've done is just taken into account moving those guys around, but keeping them together. Now I have to actually order the 3 spaces that they can sit in. The Canadian postal code system consists of 6 characters where the first, third, and fifth characters are letters, and the other characters are digits. So letter, 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 digit, digit, digit. No postal code in Canada can begin with D, F, I, O, Q, or U, but repeated letters are allowed and any digit is allowed. How many postal codes are possible? So we also start with a restriction which happens to be only the first blank, correct? Which takes off how many letters? 6 out of 26, so we're left with 20. And then it says I can repeat, so I go 26, 26, and then how many do I have for the blanks? Sadly, people will leave it like this. Remember, you need to have your dots, or else it's just a really large number with blanks and kind of spaces, and it's awkward. That's what it is. So what is our answer? Oh, 40. That? 13,520? Yeah, 1,000. The first letter of the postal code represents the province. In Ontario, all postal codes start with K, L, M, and P. How many different postal codes are possible in Ontario? 1, 2, 3, 4, 5, 6. K, L, M, and P, so I have 5. Then 10, then 26, then 10, then 26, then 10. And what do I get here?
3,380,000.
That. The first digit is an O. Should be at. Oh, stupid. An O. There should be an N in there. And a 0. I only did this because it's Monday and they mop on Friday. Okay. I don't know if they mop every day, but I know Fridays they do, and the floor's kind of clean. Okay, after that nap, I now see that it's a digit and that it's a 0, and I didn't spell it. This makes sentence structure incorrect. I'm just an idiot. It's fine. The first digit is a 0 if the region is represented. It represents as rural. I learned so much stuff when I found this question. I was like, this is so interesting. Because no joke, SON1LO is the rural town that I used to grow up in Saskatchewan. SONOVO is the other one. And then when I moved to Okotoks, it was like T1S 1P1, T1S 5P8, and T1S, I don't remember my other one. But the one is for urban and 0 is for rural. Fun fact. The more you know. All right. How many different rural postal codes are possible in Ontario? 1, 2, 3, 4, 5, 6. The first one has how many blanks? How many numbers? How many letters? 5. The second one has? Okay, thank you. Then? Then. And what do we get?
The same number with one less 0.
Makes sense. Because we dropped off the 10, right? How many even 3-digit numbers with no repeating digits? Now this one I set you up for a bit different because it kind of always gave you all the numbers in the world to do the non-repeating evens. But what if I give you this where it doesn't have all of them? So how many even 3-digit numbers? 3-digit numbers means you can't start with a 0. Even means I need to end with an even number. With no repeating digits means I'm going to have 2 cases always, correct? So I'm going to have a case where it ends in 0, and then a case where it ends in the rest of the even numbers, which is 2 and 8. Okay. So for this one, I have one option. This one I have how many?
4.
And if we want to, we can write them 1, 2, 8, 9. Say I hold the 9, hold the 0. 1, 2, 8. So now I have 3. This one I have how many? 2, hold the 2. Then I would have 1, 8, and 9, which is 3. Hold the 9. Then I have 1 and 8, which is 2. Add the 0. So then I have 12 plus 18, which is? Nice even number. How many 5-digit even numbers are there if the numbers cannot be repeated? I put these two back to back to prove that you can be given a shorter amount of digits or you can be given all the digits, but either way you still have to do the cases, correct? So 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. We've been given this question, I think, 3 times now. Once was with 5 digits, one was with 6, one was with 4, and then a 4 again, now a 5, and then a mixed one. So many options. Okay. So here we would have 0, here we'd have 2, 4, 6, or 8. So if I use the 0, I have 1, and then I have 1 to 9, which is 9. Hold the 9, 1 to 8, which is 8, then 7, then 6. This one I would have 4. Hold the 2, I would have 1, and then 3 to 9, which is 8. Hold the 1, then I would have 3 to 9, which is 7. No, because I have to add back the, so I actually have 8, then 7, then 6. And what do we get?
13,776.
I should have that memorized. So it's fine. And then I gave you this one. N plus 4, n plus 2 factorial equals 42. So we have to expand it. The first thing we should always do is rewrite the question. Now this is my biggest pet peeve. People will say, I ran out of room, because they'll start underneath the question. Or, like if it ends with the equation, they'll start at the very end and work their way under the equation, then work backwards and roll and like circle. You should never be working from the stem of the question. Like you should not be like lining yourself underneath the numbers and run out. Like if I put n plus 4, n plus 2 factorial equals 42, I'd have half this class running their equation just down here and running out of space. You should never be running right below the equation. You should never say, Mrs. Lepp, there's not enough space. You started the stem way too far over here. The first thing you should do is just rewrite it so you can work left to right. I have people working themselves out of questions all the time. That's not where you do it. You rewrite the equation and then go, right? That's the first thing you should do. So we have n plus 4, n plus 2. That's a lie. N plus 3, n plus 2 factorial. Over n plus 2 factorial equals 42. Then we get n squared plus 7n plus 12 minus 42 equals 0. N squared plus 7n minus 30 equals 0. What multiplies to give me 7 and adds to give me the negative 30? N plus
10.
and n minus. So we get n equals negative 10. Does that make sense? Can we have negative 10 for n ever?
No.
Not for factorials. Circle it, line through it, extraneous. Because we got a solution, it just doesn't work. We can't say n can't equal negative 10, or n doesn't equal negative 10, because you'd read it as n doesn't equal negative 10, but it actually did equal it. It just doesn't work. That's when we put the line through it. And then we have n equals 3. We can try it. We can go 3 plus 4 factorial divided by 3 plus 2 factorial, and you do get 42. Okay? Any question? We're going to flip to binomial theorem for the end of our note. We'll look at Pascal's triangle at a different date. We're going to look at this bad boy, which is page 13. Okay. In grade, I don't know. I know for sure in grade 10. In grade 10, if you were given like x plus 2 squared, what's the very first thing you would do? If you were given x plus 2 in brackets squared, what's the very first thing you should do? Yeah. Cross out the squared and write it twice, because that's all it means. Correct? In grade 12, same thing. Anytime you see a squared, it doesn't matter where it's going to happen, you're going to cross out the 2 and you're just going to write it out twice so that you FOIL it properly. Foiling it properly means outside, inside, or first, outside, inside, last. You're going to get 4 terms, which usually results in 3 once you collect like terms. Correct? If you forget to write it out twice, a lot of people will err because they'll just multiply the first and the last and forget the insides. You know what I mean? If it's just that squared, they'll square the front, they'll square the back, and then they'll miss the middle term. So I always say, if it's squared, you cross it off, write it out twice. Well, this is to the 4. So we're going to cross the 4 out and actually write it out 4 times, which is kind of crazy. Or it's the only time we're ever doing this, just so you know, the long root. So this is, we're going to go 3a minus 2 to the 4, because we rewrite our question, and it's going to equal 3a minus 2 times 3a minus 2 times 3a minus 2 times 3a minus 2. So 4 sucks. If you can imagine a 10 would really suck, right? And we will be doing ones with 10s and 12s and stuff like that, but we're going to use the binomial theorem, because this is a binomial, correct? 3a minus 2 is just a binomial to an exponent, correct? That's what we're going to be able to use the binomial theorem. I'm showing you the long way to prove that when I use the binomial theorem, it works. You aren't just trusting me, you're seeing that it actually works. Okay? So we want to FOIL, then FOIL. So I'm going to do these 2 first, then these 2. You can do any root you want, but that's the route I'm going to go. So 3a and 3a is 9a squared. Then 3a times negative 2 is negative 6. 3a times negative 2 is negative 6a. So I get negative 12a for the outside and the inside. And then negative 2 times negative 2 is a positive 4. And then I stop because I hit an end bracket. The bracket still exists. Now I know these are the exact same, so I'm going to get the exact same. 9a squared minus 12a plus 4. Now I have a bracket in front of another bracket, right? So I want to get this bracket into the other one. When I hit an end bracket, I stop. We agree? So I literally just have to put the first term in the first bracket into all 3, then the second one into all 3, then the third into all 3, then I'm going to have to collect like terms, and then I'm going to be done. So I'm going to get 9a squared times 9a squared is 81a to the 4, because we add exponents, we have like bases. Or is that in grade 10 as well? 9 times negative 12 is what? Negative a to the 3, a squared times a. And then 9a squared plus 4 is 36, a to the 2. Then we do the negative 12. Negative 12 times 9 is negative 108, a to the 3. Then negative 12a times negative 12a is positive 144a squared. Then negative 12a times 4 is negative 48a. And then the last term. 4 times 9a squared is positive 36a squared. 4 times negative 12a, negative 48a. 4 times 4 is positive 16. And then what do I have to do? Collect. Yeah. So I'm going to get 81 a to the 4. And then negative 108. Negative 108, I have no more a cubed, so it doesn't look like. So negative 216, a cubed. 36a squared, 144a squared, 36a squared is what? 300 and something. 316?
116.
200?
216.
216?
Yeah, 216.
Are you making me question? Meh. 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 Yeah. Need to do some adding onto the side. My brain was wanting it to make it a 3. Okay. Fixed it. 216a squared minus 48 is minus 90. Yep. It's going to start sing. Plus 16. Now we're like, that's not too bad. Yeah, because it's to a 4. What if it's to a 10? Or what if I'm missing a variable and I ask for it? Or what if I'm asking you for just the 4th term? You're doing a lot of work to just find a 4th term, right? The binomial theorem can find every single term separately, which means it's not going to be way faster than this to find the whole binomial, correct? But if I just want to find one term, the binomial theorem is faster. So I'm going to show you what the binomial theorem is. The binomial theorem is on your formula sheet. It's on the bottom left-hand side. It'll be on the next page, but I'm just going to show it to you before then. So it says, in the expansion of x plus y to the n, it needs to be x plus y to the n. It needs to be a binomial to an exponent, and the binomial needs to have a plus sign in between. See how there's a plus sign in there? That's real. Has to have a plus sign. Written in descending powers of x, so that just means like how we always write it. A to the 4, a cubed, a squared, a. You're just moving down by degrees. They'll always ask for descending powers of x, so don't let that throw you off. The general term is tk plus 1, n to k, x to the n minus k, y to the k, which sounds ridiculous, but it's actually not that bad. So it's t k plus 1 equals n c k x to the n minus k, y to the k, using the formula x plus y to the n. It needs to be in that form. So you get the x, you get the y, and you get the n directly from the binomial. That never changes. The only number that actually changes, depending on what term you're finding, is k. That's it. So we're not going to find the whole expansion here. I'm just going to make you find one of them. So I'm going to make you find the 3rd term. What is the 3rd term in descending powers on this previous example? What is the answer to the 3rd term?
Isn't it 216a squared?
Yeah, it's going to be this one. 216a squared, right? So we know that term 3, where is it over here, is 216a squared. Because I expanded it already, I know that that's the answer, correct? But how can I find it using the binomial theorem? Well, first off, I have to actually use the binomial theorem and get my x, my y, my n, so I'm going to line my binomial up. My binomial was 3a minus 2 to the 4. Do you see that? So I have to line that up under here. 3a, was it minus 2? No, I don't even remember. 3a minus 2 to the 4. That was the binomial. up top in the question. We agree? But what did I tell you it has to have in between it? A plus sign. So all you have to remember is that you can put a plus sign in between here, correct? So your x is actually 3a. Your y is actually negative 2. And your n is 4. So I'm going to write them all down to help myself out. So my x is 3a, my y's will all be replaced with negative 2, and my n will all be replaced with 4. So it doesn't matter what term I find, my x is 3a, my y is negative 2, my n is 4. Do you see how you can make the mistake and just put a 2 instead of the negative 2? If you do that, do you think they'll have the answer there? Yep. Most common error. So you always have to have a plus sign. Your formula sheet even tells you it, right? So there's going to be the error that's going to hit. One of the most common errors is forgetting to put it be your y being a negative 2. Okay? Now your k changes depending on what we're finding. All right? So I know we can go back to geometric and arithmetic of grade 11. We don't really need to remember any of that. We just need to remember that this means term 3. Correct? That's all I'm pulling from that unit. So if you remember nothing, all you need to remember is this means term 3. We agree? And I'm asking you for term 3. So we're going to line up our formula underneath, trying to find term 3. So I'm trying to find term 3. We agree? So I'm not going to just write term 3 because this is term k plus 1. So what would term 3 actually be? T, how do I get 3 here? 2 plus 1. And now I just found my k. What's my k? My k is 2. My k is always 1 less than the term I'm trying to find. We agree? So the k is going to change depending on what term you're finding. That is absolutely going to happen. The things that will not change are the x, the y, and the n. Those come from your binomial, right? Those will not change. However, your k will change. It's always 1 less than the term you're finding because it's t k plus 1, and I'm trying to find term 3. So my next line, I'm going to have t3 equals, right? When I'm working my way down, this is t2 plus 1, which is term 3. Okay, then I just fill in my numbers. So n is 4, c, k is 2, x is 3a to the 4 minus 2, and y is negative 2 to the k, which is 2. Do you see how I just literally filled it into the formula? I didn't do anything fancy. I just put numbers in for letters. Okay, now 4C2, we put into our calculator, what do we get? It is 6. So 4C2 is 6. Now this is the thing, 4 minus 2 is actually 2, we agree? Do you want to know where the next error is going to happen and they're going to have the answer to it? That 2 needs to go to the what and the what? The 3 and the a. They will have the answer to you forgetting to put the 2 to the 3. So you'll write 3a squared next. They will put that, it will be there, and it will be picked often. Trust me, it is real. It's real sad, but it's real. Okay? So the 2 will go to the 3, the 2 will go to the a, so it's going to get me 3 squared, not 3 times 2, 3 squared, which is 9, a squared. Now this 2 has to go to the 2 and the negative 1 technically that's sitting in front of there being multiplied by the 2. So any even exponent, any base to an even exponent if it's negative will turn positive, right? And any base that's negative to an odd exponent will stay negative. Because this is just negative 2 times negative 2, which is 4. Now your last step is to take all these coefficients and multiply them together. So I get t cubed equals 6 times 9 times 4, which I'm praying is 216, or this is completely backfired of epic proportion. 216 a squared. Same answer, right? So it's not like a tiny amount of steps. There's actually quite a few steps, but there's actually a better chance of you not oopsieing on doing just finding one term this way. Now you might say, well, it's not too bad. Yeah, because we did it to the power of 4, but there's going to be ones to the power of 10 and 18 and you're gonna oopsie. Actually, you're just gonna run out of paper. You're gonna need to go get like a poster board just to do one question, right? Or can I borrow the whiteboard at the back, Mrs. Lepp? So you need to go across all three, right? If you're going across 3 whiteboards, question yourself. Be like, there's got to be an easier way. All right. So could we find this whole expansion by just doing this? Yeah, I could find term 1, term 2, term 3, term 4, term 5, and then just write them in a row, and it would be that expansion. Correct? So if they wanted me to expand it, I could just find the term. Now, how many terms did come out of that? 5. But it was to the power of 4. What the heck? When it's to the power of 2 and we foiled out the power of 2, what do we always get? 3. And the reason why is this. I want term 1, and then term 2, and then term 3, and then term 4, let's say, right? This would be term k plus 1. So it would be 0 plus 1. This would be term 1 plus 1, term 2 plus 2, term 3 plus 3, term 4 plus 4. And you actually go till n. But if n is 4, 4 plus 1 is actually how many terms? 5. So it's always one more term than n. I'm going to write that down with a little star. Total number of terms. Sometimes that's all that's asked. Is n plus 1. So in this case, n was 4, so we actually got 5 terms, right? Sometimes I see people trying to expand out a massive binomial, and they're like, we don't have enough information to expand it out. It's just asking me for the total number of terms. And I'm like, okay, what's n? They're like, 20. But I don't know how to get the total number of terms. I'm like, okay, what's n? They're like, 20. I'm like, but they didn't give you enough. I'm like, what's n? They're like, 20. I'm like, what is the total number of terms? Oh, it's one more. There's 21. And they have like an entire page of binomial work. And like, they just literally wanted you to add 1 to n. That was it. So well, you'll catch yourself. You'll do it a few times where you're doing all this work and then you're like, oh, I just need to add 1 to n. Cool. Totally missed that. All right. So this is the binomial theorem. I told you it was going to come up on this next page. It shows you all the stuff that we did. I just wanted to give you a glimpse of it before we got to it because it looks overwhelming in this little box compared to when you just get explained a little bit pieces together. Just replays everything nicely in little terms. Okay, we're going to go here. Since you're geniuses, I want you to do 1 and 2. Go. So if I want the 4th term, I want t3 plus 1. So my k is 3 to get the 4th term. So I'm going to do nck. So I'm going to do 8c3. X to the 8 minus 3, y to the k, which is 3. So I'm going to get term 4 equals, what's 8c3?
56.
56. X to the 5, y cubed, done, because they didn't have any numbers on them. This one I have to remember to do what? Yeah, add the plus sign. So my x is 2x, my y is negative 5, my n is 7. So x is 2x, y is negative 5, n equals 7. K equals what? 2, because I'm looking for the 3rd term. So I'm going to go t2 plus 1 equals n, which is 7c2, 2x to the 7 minus 2. Negative 5 to the 2. So I get term 3 equals, what's 7c2? Thank you. And this is to the 5. What's 2 to the 5? 30. 2. X to the 5. And then negative 5 squared is 25. You have to watch yourselves with the negative signs and stuff, because sometimes you'll have a negative sign, sometimes you'll have a positive sign, and they'll have the alternatives to them if you mess it up, as the oopsies. Okay, what's 21 times 32 times 25? 16,800. 800. Sorry, I lost the last part. So that's term 3. Box it. Middle terms. Let's discuss middle terms. Because I need you to not just memorize or do math. I need you to understand math. Because when they give you diploma style questions, or your prof asks you a question in university, they're going to ask for understanding questions, not just you, the person who can like follow along with steps really, really well. They don't want that person. They want the person that understands what they're doing. That's why I always show you the long method and tell you not to just trust me, because I want you to see that it actually does work, so that you can have a reasoning. If say they say justify or describe or anything like that on the diploma, you'll be able to do it, because you actually understand why you're doing something, rather than just learning steps and spelling out steps. Okay? The difference between a really good math student in 30-1 or someone who can get an okay mark is someone who actually understands math. So, we said that the number of terms is what? N plus 1. We agreed to that, correct? So when we had it to the power of 4, we said there was how many terms? 5. Okay? When we said to the power, say we say to the power of 11, how many terms would there be? 12. Okay, so that's an even number of terms, correct? Okay. Do you remember in grade, somewhere in junior high, I don't remember, maybe grade 6 even, I don't even know. I'd have to go back to the curriculum. But remember when they asked you for the mean, the median, and the mode, and the mean was the average, you added them all up, you divided by how many terms there was. The mode was the one that happened the most. So you had to find the one that happened the most, and you stated it. With the mean, you always did what to figure out the mean? Do you remember? I mean, not the mean, the median, the median. The median, what did you do? Yeah. Yeah. And then find the middle term, correct? So you did it from least to greatest, and you found the middle term. What happened when you had an even number of terms? You didn't have a middle term, correct? So you had to make a middle term. So what did you do?
Yeah, you had the two that were closest in the middle, and then you add those together by 2 and find an average.
Right, because you didn't actually have a middle term. There was no such thing as a middle term. You had to make a middle term, correct? So in these cases, it'll ask for middle terms. When's the only time you can actually get a middle term?
Exponent is
When the exponent is even, but why?
because that's the only thing that will give you an odd number of terms in the complete.
Right. So their question on a diploma could just be, what type of binomials can get a middle term and why? That could just be it. And you would have to state it properly. All the information that would make sure that you had a middle term. First off, you'd have to say that your exponent has to be even, because the total number of terms is the exponent plus 1. And when you take an even number plus 1, you get a odd. And then you'll have an odd number of terms. When you have an odd number of terms, you can get a middle term. And then I would show an example. For example, if I have x plus y is 4, I would have 4 plus 1 terms, so I'd have 5. I'd have term 1, term 2, term 3, term 4, term 5. Hey, in the middle there's term 3. Term 3 is the middle term. So you give an example after. But you can't just give an example and be like, there, you understand why. Because an example just shows for that one thing it works, correct? When they ask you a question like that, you have to explain it through words, and then sure, you can solidify it with an example at the end. But you need to explain it that it works for all the ways you could get a middle term. And how is that? By saying there's an even n, because the total number of terms is n plus 1. Therefore, you get an odd number of terms. Therefore, when you have an odd number of terms, you always have a middle term. And then you can give an example. Does that make sense? So that's why you need to understand really, really well, because you might not just be asked to find a middle term. You might be asked, how can you determine a middle term? And why? They don't even give you an example, right? They'll say using a binomial x plus y with the n, right? But they have to give you that. So if we want a middle term, and the n is 10, how many terms do we get? 11, okay? If you don't know which is the middle, you can go term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, term 10, term 11. And then you can go boom, 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 boom. It's what you did when you found a median, right? And you found the middle term. It was always boom, 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 boom. You got to your middle, and then if there was 2, you averaged them. That's what we did when we did a median. Same thing here. We just have to have a median. We can't find 2 terms and average them and say, here's your middle term. There just isn't a middle term if your n is odd. Right? Yeah.
But if this question's to find the middle term, a plus b to the 11, would you just take yours?
You say there's no middle term.
Yeah, if it says why.
Yeah. They'll say justify why there's no middle term. Yeah. Because your written response on any test has to be two or 3 marks on the final. So it's either out of 2 or it's out of 3. So they can't just ask if there is, it can't be a yes or no answer, because you have to think, how can they get me 2 marks from this? Because you'll never have something out of 1. There's 3 written response out of 5 marks, 1 bullet's worth 2, 1 bullet's worth 3. They can be out of order. It can be 3 then 2 or 2 then 3, but there's 15 marks in the written. So we're finding term 4, which means K is what? If we're finding term 4, K is, Nathan? Oh, that is why you don't do messy writing. That totally looks like a 4 to me. Good thing we have you here, Nathan. When you're finding term 6, what are we saying K is? 5. So we're doing T5 plus 1 equals, and then this is our X, this is our Y, this is our N. So X is A, Y is B, N is 10, K is 5. On a test, I would never be messy. I'm like super crazy about all my clear writing. So we do T 5 plus 1, N is 10, C 5, A to the 10 minus 5, B to the 5. So we get term 6. What's 10C5? Pardon? Thank you. A to the 5, B to the 5. And then you would write a statement, because does this say middle term on it, guys? I boxed it, but does that say middle term? Are we to assume that that's the middle term because you boxed it? If ever you're saying, well, I assume they, stop yourself and be like, dang it, I'm losing 0.5, at least. If you're going, I assume that, trust me, you're losing 0.5. If there's an assumption, the only way you get full marks is if there's absolutely, if your answer is perfection. If your answer is perfection and there's no oopsies, or anyways, if someone looked at this and had no clue how to do the math, they could figure it out, and they would know the answer. You box T6 equals, all that says is T6 is 252, A5, B5. And what did I ask you to find me? The middle term. So what do you need to still do? The middle term is 252, A5, B5. That's great that T6 is that, but that's an assumption that you're saying, I box it so they know it's the middle term. I assume that is a scary place to be. Don't assume. It's a very, very scary place to be. You're losing probably 0.5 on a question. It makes me sad. So we have to always say the middle term. They didn't ask me for T6. They asked me for the middle term. The middle term is 252. A5, B5. Okay. So we're going to look at number 4. The term with Y5. Okay? The term with Y5. We're going to do this one together, and I'm going to let you work on the other one and see. Up until now, it's been easy, because I asked you for like term 2 or term 5, and you just say K is 1 less. Or ask for the middle, worst case scenario, you find out the middle term, say K is 1 less. Like the middle term is just like a tiny bit harder than the previous ones, but it still kind of gives you the middle term. It still gives you the term number, right? But if they ask me for Y to the 5, so if ever you're stuck and you're like, I don't know what term that is, if they don't directly give you the term, do this every single time. We know N, we know X, we know Y. Every single time that does not change, correct? Because once we're given the binomial, we know all 3 of those. The only thing we do not know is K. Do we agree? So let's fill in what we do know. We know X is 5. Please don't change this around and be like, I like when the Y is first. Don't do that. X is 5 plus Y is negative 2Y, N is 8. And I'm going to rewrite that. X equals 5. Y equals negative 2Y. N equals 8. And you're true to say here, okay, I need the one with Y to the 5, but I don't know what K is. Correct? So if you're ever stuck, fill in what you do know and leave a box for stuff you don't know. Okay? And then see if that's helpful. That's what I was doing. So I'm going to go T box plus 1, because I don't know what K is. I know everything else, I can fill it all in. Then I get equals N, which is 8, C box. And then I get X, which is 5, to the 8 minus box. And then I get Y, which is negative 2Y to the box. And all those boxes are the same, right? They're all K. So if I can figure out what one of those boxes are, I can figure out every box. We agree? Is this helpful in any way to figure out what term is y to the 5 in it? We have a y sitting in only the last bracket, correct? How do I get that term to have a y to the 5? Yeah, the box has to be a 5 for that last box, correct? Therefore, the box is k. K is 5. That's it. So if you remember when you're stuck to fill in everything you do know and put boxes for what you don't know, which will always be k, then you can find out what it is. I know I need y to the 5. I know this is the only y sitting here. So I know the box has to be a 5. Well, this box has to be a 5, this box has to be a 5, this box has to be a 5, this box has to be a 5. This one is asking for the term. If it asks for the term number, I would be done. What's the term number? 6. So if it says term number, you just give the term number. If it says determine the term, or this one, the term of, I have to find the whole thing. Correct? That's the difference. So if it said term number, I would say term 6, and I'd be done. So this is term 6 equals, what's 8c5? And then this is 5 to the 3, which is 125. And then we get negative 2 to the 5, which is actually negative 32y5. And then I need to put all my coefficients together. T6 equals what? Negative a large number.
280,000. Isn't 8C556? That's what I want.
Yeah, 85 is 56.
Keep up. So what's the big number?
Negative 224,000.
And how do we end this? This is term 6 equals. Did it ask me for term 6? No, it says the term with the y5. So the term with y to the 5, to the power of 5, is and you're flip over. I challenge you to this one. What is a constant term? A consonant is not a vowel. True, true, true. What is a constant term? Yeah. Well, without a variable, but what? It's just a number. It'll remain constant. So if I do function notation, let's say I do, I'm going to erase this. Don't write this down. Say I give you f of x equals x squared plus 7x plus 3. Nathan is saying that's the constant term, and he's completely correct. Because f of x means I can fill anything in for x. We agree? So I fill in a 2. This will become 4. This will become 28. This will stay 3. And I fill in a negative 1. This would be 1. This would be negative 7. This would be 3. This is the only one that ever remains constant because it doesn't have a variable on it, aka why it's called constant. Okay? So I want the term where those x's go bye-bye. Now let's think about it. If I gave you an x to the 4 up here, you can put it over 1. And I have an x to the something down here. What does this something have to be in order for them to go bye-bye? This has to be a 4. Because x to the 4 divided by x to the 4 is 1. They would cancel. We agree? So you need to figure out some sort of something where the x on the top in the numerator is going to be the same as the x in the denominator, and they're going to go bye-bye. We agree? I know x. I know y. I know n. What do I not know? Okay. What am I going to put? Boxes and try and get something that's going to go bye-bye. You all try it. You can go on the whiteboards if you want. You can go on your paper if you want. I don't really care. Giver. So I'm going to fill in what I do know. So I know x is 2x. I know y is 1 over x to the 2. And negative. And n is 15. And I don't know k. So I'm going to go t blank plus 1 equals 2x. Whoa, I really forgot the n there. N, which is 15, c box, x, which is 2x to the 15 minus the box, and then negative 1 over x squared to the box. Now, I do guess and check till I get it. I can do a bit more better guess and checks. I've done these for forever. I can do it really quick. But if you want, start at one number and work your way down till the two variables match, right? I know that this one is x to the 1, and I know this is x to the 2. So this number, this exponent's going to have to be bigger than this one because this one's immediately doubling all of them. Okay? So if I try 1, let's pretend I try 1. This one's going to be, I don't even care the numbers that's with it. I just care about the variables because they need to match and go away. So if I try 1, this is going to be x to the 14, right? And this is going to be x to the 2. Do they match? No. So I'm going to try 2. This is going to be x to the 13. This is going to be x to the 4. Still doesn't match. Say I try 3. This is going to be x to the 12, x to the 6. We're getting closer, but they're still not the same. I'm going to try 4. Now I have x to the 11, x to the 8. Closer, still not same. Then I try 5. So this is going to be x to the what? 10, and this is x to the what? 10. Do they match now? So what's every box going to be? 5, and that means k is 5, right? Which means this is actually term 6. So if they ask me for what term is the constant term, what term number is the constant term, you'd say 6. If they ask you what the term is, which this one did, I have to actually figure it out. So this is going to be 5, and this is going to be 5. So term 6 equals, what's 15C5? 3,300? 3,030?
No, 3003.
3003.
It's all so many zero. Okay, erase.
It's 2 zeros.
I was thinking like 3,300, 3,030. You're meaning 3,003. Okay, so this is 2 to the 10. Don't forget to raise the 2 to the 10. I'm telling you, because everything else is harder, that's when the sillies start happening, right? What's 2 to the 10? 3,003. I'm just kidding. Sorry? 1,020. X to the 10. And then, okay. When I have a -1, I pray and hope you get an exponent that's odd. Because the chance of you, if it's even, remembering to go -1 to be even, changing it to be even positive, is still good. The chance of you doing that is still really good. The chance of you oopsing is still kind of okay, which is not a place I want to be. So when I see -1 to the 5, I'm like, woohoo! They don't have to even remember to distribute, because it works out the same. If you forgot to distribute or you did, we don't know. We can't see your brain. If it's even and you forget to distribute, we can see it blatantly because you left it as a -1, right? Odd, we're like, if you forgot, it still works out. So this is going to be -1 to the 5, which is -1 over x to the 10. If there were to be an error, I would say it's the 2 to the 10, and this one to the -5 was to like a 4 or something. That's the other place where the error happens. If you can get to this point. Some people just are like, Lepp, I never can do these. These just make me cry and die inside. Okay? I hope that's not you. I hope you just put the boxes and you practice till you can get them to work. So let's put the numbers together. These ones cancel, and we get t to the 6 equals negative some large number. Some large constant. What is the some large constant? What's the number? What's the number?
3,755,072. That's not a number.
It's okay. 3, what is it? Just give me the numbers.
75072.
You did say it right. My brain quit after you said 300. Or you said 3 million, and I was like, I blanked. You were good. You were good. Boom. And I'm done, right? No, because I'm assuming that they believe that that is the what? The constant. And I assume things go poorly. So we're going to go the constant. It should be capitals, but I'm not going to go back. The constant term is -3,075,078. 6 and 7 we're gonna go over tomorrow. Ooh, that's sweet. Your homework for today, I'm gonna write it right here, and then I'll erase that. Page 542 onwards, numbers. Wow, this chair is awesome. Stop making the noise, it's disappointing. 7 BCD. (18 and 19). We don't need 7 million to prove you can do this. We just need you to do those. Okay? That's it.